Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Alright, for today's lab, we will study about common emitter amplifier. Basically, it's a BJT amplifier. So the objective of the experiment is to know the effect of the frequency on the gain of a common emitter amplifier. Basically, we want to see the frequency response of a CE amplifier. Alright, and we also will measure the input impedance, output impedance, and also the phase relationship of a CE amplifier. Alright, so to learn more about the theory and the details on the common emitter amplifier, you can watch this link. Basically, it's covered in your electronic circuit, electronics and also electronic circuits. And for this lab, the circuit diagram is looks like this one. Alright, so as you can see, this is the common emitter amplifier. It's an NPN junctions. So for the Rin, okay, the input impedance, we will measure from here to here, okay, and then the output is from here to the ground. Okay, so this is the Rout and Rin. Okay, so when you simulate in PSpice, you will use this graph. Basically, this part is a bit different from the circuit given in the manual, so you can use this one. Okay, so what else is different? I think that's all, because we have the different resistor here, but you just use as 14K in this value. Okay, alright, so the result of the frequency response of a CE amplifier is actually looks like this, the frequency response. Okay, so for this one is a first cutoff and this one is the second cutoff. So in this experiment, you will varies the frequency. Okay, the frequency will varies from certain frequency given, and then you will measure the amplifier gain. Okay, so the amplifier gain will have this static value from a certain frequency, which from the first cutoff to the second cutoff. So this one is we call it as midband. Okay, so the amplification will maintain from here to here. So the cutoff, as we know, is actually minus 3 dB from here. Okay, or we can say measure it as the maximum amplifier gain multiplied by square root 2, or 0.707. Okay, so you will vary the frequency and measure the gain. V out divided V in. Okay, and then what you have also need to measure is the input impedance. So this is the theoretical values of the input impedance, but for the measurement, so it's better if you could show the measured from the one that I have shown here. Okay, the Rin and also the Rout, output impedance and input impedance. Okay, this is also the output impedance by theoretical. Okay, so for the common emitter amplifier, basically we want to amplify the signal. Okay, so if we have put some small value here, it will be amplified, but the amplification is not the same phase. Okay, so this is the input version. Okay, and this is the output version. So the output values will be 180-degree phase shift from the input. Okay, so that means it will be amplified and the phase shift also different. So if you could also shows this one in result where you plot the V out and V in, okay, together and show the difference of the phase. Okay, so this is the phase relationship of a common emitter amplifier. So this is what you're going to get for the PSpice simulation. Okay, so if the input is maximum, okay, so the output will be minus different phase, of course, and then the most minus, the most negative value, right? And so on and so forth, right? The rest also the same. Okay, this is for the VI and V out of the phase relationship. Okay, so I hope I will also upload the manuals and this slideshow. If you have anything, you can text me or private message me in the WhatsApp. All right, so that's all. Thank you very much.